To get started about today's talk, we'll be going over fertigation best management practices in organic production systems. And our first speaker is Dr. Joji Morimoto. Joji is a soil scientist, agroecologist, and a University of California Cooperative Extension Specialist for organic production systems. He is based out of UC Santa Cruz for agroecology. His research and extension efforts focus on fertility and soil-borne disease management in organic vegetables and strawberries. With his statewide responsibilities, he is also networking with organic system researchers across the state to serve diverse organic communities throughout California. Let's go ahead and welcome Dr. Morimoto to give his talk. Joji, if you want to go ahead and share your screen. All right, thank you.
All right, can you hear me? Okay. All right, good afternoon, everyone. My name is Joji Muramoto. I'm glad to be here today. And I'm going to talk about fertigation in organic production systems today. So let's get started. So here's the outline of my talk. First, fertigation, what is it and why is it? And then the second part is the main part, fertigation in organic systems. I'm going to talk about types of organic fertilizers for fertigation and the organic specific factors to think about when you do organic fertigation. And lastly, I'm going to show you a case study in organic strawberries, how to use fertigation. Just a case study. All right, let's get started. So fertigation is, the kind of, word combined fertilizer in irrigation. So, which means liquid or water-soluble organic fertilizer applications through irrigation system. That's the fertigation. So it can be drip irrigation, sprinkler irrigation, or combinations. But today, I'm going to focus on drip irrigation systems. And then Mike is going to talk about details of how to do drip fertigation. And I'm going to more talk about the materials, what kind of materials are available for organic fertigation. Fertigation is mainly used for high-value crops, including berries, strawberries, canberries, vegetables, especially long-growing season crops like tomatoes, peppers, and so forth. And sometimes, lettuce and spinach as well. And then tree fruits and ornamentals. The benefit of fertigation is it allows fertilizer application based on plant demands. Especially, it can improve synchrony of nitrogen supply by fertilizers and nitrogen demand by plants. I'm going to focus today on nitrogen, especially that's because nitrogen is, as you know, essential major element. Plants needs a relatively large amount for plant growth in different stages. Now, synchrony is a kind of interesting word, but it's a common sense concept. Synchronizing nitrogen supply with nitrogen demand is important. And that means matching nitrogen supply with nitrogen demand of crop in terms of amount and timing. Figure on your right shows the asynchrony, not synchronized example of a nitrogen supply and demand. And the dark curved part is nitrogen supply, and then white part is nitrogen demand by plants. So in this case, front part, before nitrogen demand happens, that's kind of nitrogen that are not used by plants, which is vulnerable for loss. So we don't want that to happen. We like to reduce that kind of asynchrony and trying to synchronize nitrogen supply and demand as much as possible. So synchronization is important for efficient use of nitrogen resources, reducing nitrogen fertilizer cost, and improved crop yield and quality. Nitrogen affects both, and protecting groundwater and ground and surface water from nitrate contamination. which is related to the complying with the groundwater quality regulations as well. So fertigation in organic systems also used for a good tool for improving nitrogen synchrony in long season organic crops, especially strawberries, cranberries, tomatoes, peppers, and so forth. And in particularly organic strawberries, this is the only practical way to apply significant amount of in-season nitrogen fertilizers because strawberry use plastic culture. And then there's no other way to apply significant amount of nitrogen during the long season. And also, organic nitrogen management tends to be front-loaded. I'm going to explain what it means in a minute. And then, so that is not very good. And then those kind of fertigation can improve the synchrony. This is an example of organic tomato growth and nitrogen uptake and nitrogen provision to organic tomatoes. This is data by Margaret Lloyd. I think it was from UC Davis. So nitrogen was provided from multiple sources, from soil. This is soil organic matter mineralization, and the cover crop was incorporated in April, and the poultry manure compost was applied. Granular fertilizer was applied before planting, and irrigation water contains some nitrate. So combination of all of these fulfill the nitrogen demand of tomato crops. However, it's very front-loaded. So this part, when plants are still small, if you accumulate this kind of amount of inorganic nitrogen, mostly nitrate form in the soil, this nitrate is vulnerable for loss if irrigation is not managed well. And if you have applied too much water, those nitrate in the soil can be easily lost before plants use it. So there must be a better way to apply nitrogen. So that's one benefit of fertigation. I'm going to show you example of the strawberry production system. And then there's 3 different types and sources of organic liquid fertilizer for fertigation. And there's one solid organic fertilizer too that can be used for fertigation as well. I'm going to talk about it in a minute. So 3 types. First one is plant-based. Traditional one is including kelp, seaweed extract, compost tea, banana peels, and coffee grounds, and so forth. Usually, nitrogen content is pretty low, 1 to 3%. Different kinds of mixture is available these days, so it can be higher, but this is just an example. And another plant-based fertilizer, organic fertilizer, that are kind of new one is soy protein hydrolysate. It's a solid, a powder, but water soluble. It's completely dissolved in water. And also, and then nitrogen content is pretty high, 14%, and that's available commercially. And then not only works as a nitrogen fertilizer, it's multiple papers, peer-reviewed papers, indicated that this can work as also a biostimulant. So that's kind of an interesting product, relatively new product. And the second type is animal-based. And then traditional one, including fish emulsion, blood meal, guano, manure-based. Nitrogen content varies from 2 to 8%, just an example. And another new one for manure-based one is the ammonium and nitrate organic fertilizers. This is ammonia is extracted from manure, biological process, and then convert part of ammonia into nitrate. And there are 2 kinds of this type of fertilizer: straight ammonium, 4 to 7%, or a half of ammonia is converted to nitrate using nitrification process. So those are kind of relatively new type of organic fertilizer. This is liquid form. can be used for fertigation. And the last type is fermented processed organic liquid fertilizer. Biodigested product, humic acid, micro enhanced formulas, and so forth. Those are that itself is not relatively low nitrogen content. And then when you use those kind of organic fertilizers for fertigation, there are two important factors to consider. The first one is the nitrogen mineralization and CN ratio of the organic fertilizers. And in conventional systems, typically, this is just a typical example for conventional systems, nitrogen dynamics. Solid synthetic fertilizers are used, solid or liquid synthetic fertilizers are used and applied in organic nitrogen form, ammonium nitrate, well, urea or something, but the mostly plant available form of nitrogen is applied directly. So, and to meet the crop demand. In contrast, in organic systems, most of organic fertilizer, nitrogen in there is in organic form, which is not plant available form. So it has to go through a biological process called mineralization to release inorganic nitrogen, the plant available form. First to ammonia, then turn into nitrate through another biological process called nitrification. So organic nitrogen management is inherently more complex and unpredictable. Yeah. And then also mineralization process is a biologically mediated. So it can be affected by environmental factors such as soil temperature, moisture, pH, and oxygen content in the soil. And then recently developed liquid ammonia or nitrate organic fertilizers are kind of exception. A purely, ammonia and nitrate form, so it doesn't have any organic form of nitrogen. So it works as like synthetic fertilizers in that sense. Now, talk about the organic liquid fertilizer. Nitrogen mineralization patterns of varying organic fertilizer. This chart shows the different kind of organic fertilizers mineralization rate incubation study in the lab. For example, guano on top, it has more than 50% of inorganic nitrogen to begin with, and the organic part is turning to mineral inorganic form up to total 85% after 80 days in the soil. That's how you read this chart. So 85% of guano, total nitrogen, becomes plant available in 80 days. So liquid fertilizers in this experiment, it was average of multiple liquid organic fertilizers. It contained about 10% of inorganic nitrogen to begin with. And then once you apply it into the soil, mineralize relatively quickly by microbes. And at the end of 80 days, about 60% were mineralized. So what it means, let's think about one example. If you apply 10 gallons per acre of liquid organic fertilizer with density 9 pounds per gallon, and label said 300, and mineralization rate is 60%. In this case, actually, plant available nitrogen you applied per acre is 10 gallons multiplied by 9. It's its density, pounds per gallon, make it 90 pounds per acre you applied, and then 3%. And then 60% of these are plant available form. So you applied 1.6 plant available nitrogen per acre through this application. That's how you calculate it. And the CN ratio is a total amount ratio of total carbon content and total nitrogen content of amendment. And it can show a strong negative correlation with mineralizable nitrogen percent of organic amendments. This is one example work by Lazicki et al. So x-axis shows CN ratio. Higher the CN ratio, the lower the mineralizable nitrogen. So that in this case, liquid organic fertilizer included. That's right here on the black dot, red circle. And then that about CN ratio is about 6 and mineralization rate is 70%. And then it works for certain type of among certain type of organic fertilizer like this example, but depends on the organic material, such as different crop residue might have different carbon compounds and may shows the different kind of relationship between CN and mineralization. So, CN ratio is just an indicator, the calculation of total amount of total carbon and nitrogen doesn't take into account the quality of carbon. So those kind of relationship has to be established for different amount amendment, or for example, different cover crops. Cover crop has different kind of relationship, like from this one. But CN ratio can be used to estimate mineralization rate. That's the point. And then this is the relatively new work in our lab showing soy protein hydrosate mineralization in the soil. We tested two kinds of product and then either apply the powder or dissolve in the water. Compare it, and then mineralization rate was like 60%. All right, and the second important factor is Krogin drip tape emitters. That could be that had been the issue for traditional liquid organic fertilizer containing particles, and then microbes in the liquid organic fertilizer can also clog emitters. And some organic strawberry growers used to apply extra drip tapes in case clogging happens in the middle of the season. But if you use soy protein hydrosate or ammonium nitrate organic fertilizers, that's not an issue. So I'm going to show you the case study very quickly using fertigation to improve synchrony of nitrogen supply with nitrogen demand in organic strawberry production. So let's say target yield of strawberry is like 60,000 pounds marketable yield per acre, which absorb about 160 pounds of nitrogen per acre. And the feather mill 1.1 ton per acre can provide this amount of nitrogen, plant available nitrogen, if you apply pre-plant. However, as you know, strawberry planted in November, and then winter time is the rainy season for coastal California. So this things much rain before plants really absorb nitrogen, and those amount mineralized nitrogen can be lost before nitrogen absorbs. So better way to apply fertilizer is to apply smaller amount of fertilizer, pre-plant fertilizer, and add smaller, like a spoon feed, liquid organic fertilizers. In this case, every 2 weeks, 9 application to meet the nitrogen demand. That can be much more synchronized in supply and demand. So lastly, cost of organic fertilizers. Liquid organic fertilizer is more expensive than organic fertilizer per pounds of nitrogen, per plant available nitrogen. And then I just show some examples of recent prices, but I don't have an exact price for ammonium nitrate organic fertilizers, but I heard it's comparable to liquid organic fertilizers. So, But basically, it's more expensive than solid organic fertilizers. That's another kind of con of this type of fertilizer. And then this is the last slide. And organic ammonium nitrate fertilizers recently becomes available one. I think there are two things to point out. Uh, this works like, chemical fertilizer. So if you're not careful, easy to accumulate excess inorganic nitrogen in the soil and plants, which can cause environmental pollution easily and increase nitrate in vegetables, leafy greens, and high nitrate means reduced sugar content and can reduce the shelf life and vitamin content in crops too. And also, if it's straight nitrate and nitrate ammonium, so it doesn't provide carbon that feed soil microbes. So that has to be applied in other way in organic system. With that, I'll be happy to answer any questions. Thank you very much.
So for our next speaker, we have Dr. Michael Kahn, who is going to be presenting today about fertigation systems, their maintenance. So those of you that are familiar with Michael, as you know, he is our irrigation and water resources farm advisor on the Central Coast. He's located out of the Monterey County office. He has over 25 years of research and extension experience, and for the past 20 years, his research and extension activities are focused in the areas of irrigation technology, water management of vegetable and horticultural crops, protection of water quality, and food safety. He has led the development of Crop Manage, an online decision support tool for water and nutrient management of vegetables, and this started back in 2011, which is now being adapted for not just vegetable crops, but also berry, tree, and forage crops. Michael, if you want to go ahead and share your screen.
All right. Well, thanks for the invitation to participate. I think I will concentrate on the mechanics of doing fertigation. Joji gave you a good overview of the nutrient management side. But I do want to mention, that the main benefit of fertigation is that you can better match the fertilizer applications with the crop demands. Um, Let me make sure this isn't in your way here. Okay. Um, so, if you think about, um, let's see if I can get this to go. Okay. The uptake rate of a lettuce crop or a leafy green crop, very early on, as Joji mentioned, there's not much an uptake until you get almost halfway through the season, and then it's quite rapid. So with fertigation, you can hold off on applying the fertilizer till the point where the crop needs it and really spoon feed it like Joji demonstrated with that case study with strawberries. So just give you a description of what you will read in the textbooks about fertigation practices, the best management practices for drip. And that's what I'll concentrate on today. You can fertigate through sprinklers. People fertigate through furrow irrigation, but I'm going to concentrate on drip because that's probably the most challenging to do. So the irrigation industry recommends for microsystems inject in the middle 50% of the irrigation cycle or in the middle third of the irrigation cycle. So you irrigate for 25% of the time you're planting without fertigating. In the middle 50%, you would inject fertilizer, and then you have 50%, the last 25% with clean water to flush out the fertilizer. What we observed over the years are all sorts of practices that growers do. Usually it's at short injection times at various different times during the irrigation cycle. So we don't really see these adherence to the industry standards. If you're trying to get a nice uniform fertigation application, the prerequisites, I would say, are make sure your irrigation system is distributing or applying water very uniformly in the field. And also, very good idea, and in many cases, it's the law to have backflow prevention. So none of the fertilizer you're injecting can get into your water source, which in some cases would be a well. So make sure your wells have the required backflow prevention. And there's various ways to inject fertilizer. We can use Venturis, which have a restriction and inside there and create a low pressure, a vacuum that pulls the fertilizer into the water stream. We use diaphragm pumps, piston pumps that could be water driven or electric or gas, and centrifugal pumps, which are probably the most common. These little Honda pumps, maybe that you just inject the fertilizer in. In greenhouses, I often see these water-driven dosatron pumps that someone was asking about, and they work really well. But if you're trying to get a lot of fertilizer in quickly because you have a big field, then a lot of growers choose the centrifugal pumps. Now, a number of years ago, we asked the question, how uniform are growers fertigating? And so we went to a number of commercial lettuce fields in the Salinas Valley and put drip emitters on the drip tape. And then we had them in different parts of the field. And then the growers were fertigating at that time. And so we could evaluate how uniform the fertilizer is going in different areas of the field. We also measured the uniformity of the application of the drip system there in each of these fields. So here you see 11 fields of different lettuces and different bed widths. And one column here is showing the irrigation uniformity, called the distribution uniformity. Let's see if I can find the pointer here. Screen pointer there. So here's the DU, distribution uniformity. Sometimes they're high, sometimes quite low. And you generally see when you have low application uniformity with your drip system, you get a very low application uniformity with your fertilizer, right? In all these cases. And you'll also notice there's one case here, high uniformity, and I should say, 100% is perfect uniformity. So 38's very poor uniformity. 88's quite good, but you see the fertilizer uniformity still wasn't very high. And I'll explain that later. If I don't, please ask why it wasn't uniform, because we figured it out. We also evaluated what percentage of the emitters were plugged in these drip systems and what was the average pressure of the drip system. And you can see this case here, low uniformity, low pressure. And a lot of drip systems, they don't perform very well if you run them at too low of a pressure. This case, pretty low uniformity, and a lot of the emitters were plugged, plus it was run at a low pressure. So it just really shows you that you are not going to get that fertilizer out very uniformly if your drip system doesn't work properly. So a few words of wisdom about how you can get a uniform fertigation application. The most important part is don't start injecting until the drip system is fully pressurized and you fixed all your leaks, right? You don't want your fertilizer going out where you have a big leak in the drip system. You want to inject upstream of a filter to prevent clogging of the emitters. And we'll talk more about that later. Uh, Inject as slowly as possible to provide a uniform distribution in the soil profile. If you put all the fertilizer up front and then you have nice clean water, you might flush some of that nitrogen down deeper in the profile. Not too much of a problem for organic fertilizers, but more for anything that was more in the chemical form, especially the nitrate form. And it is true, some of these organic fertilizers, by the time you get them, they've mineralized, and a good portion of that nitrogen might be in the nitrate form. After injecting, you want to irrigate a sufficient time with clean water to flush out all the injected fertilizer from the drip system, and then avoid over-irrigating and subsequent irrigations to prevent leaching losses of the nitrate form of nitrogen. So important concept in fertigation is to understand the travel time. How long does it take for that fertilizer to get to the furthest point in your irrigation system? And so you might be injecting here at the valve. The furthest point is this end of this drip line here. And that's going to depend on the injection location, the tape discharge rate, or we say flow rate, and the length of the beds. So this figure is from research that Blaine Hansen, was emeritus irrigation specialist, developed. And it's just showing you as you go with different lateral lengths and different flow rates of tape or micro sprinklers, what the travel time is to get to the end. And you can see the longer your tape or lateral is, the longer travel time. But also if you have a lower discharge rate, it's going to take longer for it to travel. And just to illustrate this more graphically, we would in the past do these type of trainings with growers out in the field where we put out a small drip system and we would inject dye into this system, and everyone would measure when that dye arrived, and also we would measure the uniformity of the irrigation system at the same time. But this is just sort of a graphics of sort of how it would go. So we'd inject at this point, and just imagine we're injecting some red food dye into the water. So this is at 0 minutes. 1 minute after it starts distributing. Here's at 15 minutes. Then we're 25 minutes in, and so it's already starting to flush out in the, close to the valve, and the line's close to the valve, but it still hasn't arrived at the furthest point. Now 35 minutes in, it's starting to flush out in most of the lines. 50 minutes, and see it's taking longer and longer. Now it's out at 70 minutes. What's going on is the rate of movement of that dye or that fertilizer really depends on how many emitters are ahead of it. So as you get closer and closer to the end of that drip line, you have less and less emitters, so the flow rate really starts dropping, if that makes any sense. So you can inject really fast, but the water flow is going to determine how fast that fertilizer moves into the irrigation system. So once you understand the travel time, you can understand or calculate what's the minimum time you need to irrigate to flush out that fertilizer. So we usually say it's got to be longer than the injection time. You were injecting the fertilizer, right? Plus the travel time. So if travel time was 40 minutes, you were injecting 15 minutes, you would have to be irrigating at least 65 minutes, right, to get that fertilizer completely flushed out. That is a minimum. And if you were doing some irrigating beforehand, before you put the fertilizer on, um, you would have to add that time too. So a little more wisdom, your flush time should be greater than your travel time. And also, injecting slower is better than fast. That gives you a more even distribution of the fertilizer in the soil profile. Also, sometimes you're just limited on how long you can irrigate because you have to do a lot of blocks. If you have a lot of different blocks, you have to irrigate. So having an understanding of the travel time will help you determine what is the minimum time you need to irrigate. And this is from one of those demonstrations we've done with growers out in the field. And you could see a slow injection versus a little faster injection. And even the slow injection is pretty fast, but for demonstration purposes, and it was a small block, we called 10 minutes slow. And at first, we had 2 cups. So half of the irrigation we collected the dye in cup one, and then we switched to cup two for the second half of the irrigation. So you can see with the slow injection, doesn't look too much different than the fast injection for cup one. But at the latter part of the irrigation, cup two, which is the slower irrigation, the fertilizer or the dye looks a little more uniform than with the fast injection. Something else to consider is where are you injecting your fertilizer? And also, is there sufficient distance for mixing that fertilizer before you branch out in your irrigation system? So a lot of people are injecting fertilizer at the block level or at the field level or at their water source at the pump. So if you are injecting at, say, a well or a pump near your water source, there can be travel time to get to your field before it even gets the fertilizer distributes into the field. And so in this case, you see it's like 60 minutes that it takes for that water to get there. But notice there's these other branches in the main line or the submains, and maybe the valve to close it is over here or over here, and so that fertilizer is going to migrate into some of these branches. And so when you flush out the system, it's going to take a lot longer because you got some of that fertilizer in a dead end branch of your irrigation system. And so a nice sort of exercise is take some food dye and figure out how much flush time you need to actually get everything out of your irrigation system. And you can use a little food grade dye to figure that out. Some people do it by injecting a little bleach in the water too. When you're injecting at the irrigation block, that's something we frequently see with our strawberry growers. They'll inject, say, here, and the water is branching out quickly to the left and the right. And you can see if you had more fertilizer taking a right-hand turn than the left-hand turn, well, this side of the block's going to get less fertilizer, which gets me back to why that one field, had 88% uniformity, but very low uniformity with the fertilizer. That was the case. They injected right at the block, and more of the fertilizer went on one side of the field than the other side of the field. And they had a very poor uniformity in terms of the distribution of the fertilizer. So if you are injecting at the block, it's good to have a filter. It's always good to have a filter so you don't clog the drip emitters, but it also will mix that fertilizer with the irrigation water. So it's nice and uniform before it starts distributing and branching out in the irrigation system. This is just an example of a portable filter system for vegetables that's used. And so they inject right here, and then the fertilizer goes out a lot more uniformly in the system. You can also use these injection quills that you can uh, put into the pipe, and they deliver the fertilizer right in the middle of the flow in the center of the pipe, which helps mix that fertilizer very quickly with the water stream. Uh, there's static mixers is another way to get that fertilizer quickly mixed with the water. They do cause some pressure loss, and usually you're going to have to take some water off the main stream. You inject it, and then downstream you have this static mixer, and then the fertilizer goes back into the water. So those can help just quickly getting that fertilizer mixed with the water so that you have a nice uniform application. Now, Joji talked a lot about the different organic fertilizers. The main thing I want to say is all these, for example, this is a while back, but the Omri program, all said that all of these are water soluble. But I could tell you many of them have a lot of solids, and they can clog your drip system. And if you're going to have your drip system in the ground for quite a few months, you might start losing the uniformity of that system if they get clogged. And so really, I do recommend, injecting before a filter. Now, screen filters have a lot less filtering capacity than, say, disc or even sand media filters. But the problem is, you can't put a sand media filter right there out at the block. Disc filters also usually are sort of a system that needs some automatic flushing. But that's the reality. You're going to have to, if you want to protect your drip system, you're going to have to inject before a filter. However, there's a lot of cases where growers using organic products are not injecting before the filter. And so what they're doing is flushing their drip lines like every week. And if they don't flush them, then you get a buildup of sediment in the drip lines and you start clogging the emitters. One tool we recommend is at the end of the drip lines, there's these that you can put on. They're called flush valves. And so they're spring loaded, and the valve will open when there's not much pressure in the system. So every time you start up the system and turn off the system, you get a flush. And so that really helps keeping the material from clogging the emitters. But also, you could choose fertilizers that have less solids in them. So you could sort of test that by just putting that fertilizer in a jar and mixing it with some water and seeing how many solids come out. Some growers dilute the fertilizer with water, and so that way they're not putting so many solids in right away. And certainly you have some more ability to filter them out. And then, periodically you could get bacterial growth inside these systems. So having some bleach applications to kill any growing bacteria in that drip line would also be helpful for preventing, the just plugging of those emitters. So I guess I want to summarize, best practices for fertigation are assuring your irrigation system has a high distribution uniformity. Remember to begin injecting fertilizer after the system fully pressurizes and you fixed all the leaks. Try to inject before a filter. And if you can't, you need to flush out your lines very frequently. Uh, Assure the fertilizer completely mixes before it branches in the irrigation system. Inject as slowly as possible for the amount of time you have for irrigating, and irrigate a sufficient time for all the fertilizer to completely flush out. Use good water management techniques, and remember, apply the right amount of fertilizer for what your crop needs. So with that, happy to answer any questions.